today. So if you don't have printed notes, go ahead and write down the information, answer the question, and then we'll come together as a class to verify what you have written down is right, okay? Okay, so we'll take about 3 minutes. This is all the notes we have today. Then I'll hand back your quiz and go over your homework. I'll walk around. Remember, if you need to, go back to the graph that we finished yesterday. We graphed all of these already. Now we just have to answer. I want you to try everything that you can. If there's certain boxes that you're so not sure on, that's okay. Let's see if it comes out. Remember, we graphed these out already, didn't we? Where would you find these? Are these graphed out already? I'll need to check really quickly. Are these already graphed? Are they functioning the same? Check the views. So that's okay. So these are already graphed. Okay. Yeah. So these are already graphed on the previous page. So you can go back and reverse your if you need to. Okay, can you turn to your shoulder partner and talk about it? So I'll put 3 minutes on for you guys to talk about it. So turn to your shoulder partner. So you two, please communicate. Okay. Yeah, you guys can communicate here, and then you guys can communicate. Okay, if you get stuck, you two can talk to each other, and then you two girls can talk to one another. You two talk to one another. Look back at all the ones we did. You guys compare answers? Yeah. If you're not done, maybe work together to get that done. Yeah, sorry, dear. Are you done with the check for use?
Yeah.
Okay, can you guys compare answers or work together to make sure the answers are... If you're not done, then work together to get it done. If you're done, then compare answers. Did you want to save for those? I have like a hole puncher and save it over there. Yeah. So order them by pages, and then there's a hole puncher. Make sure the hole punchers line up correctly, and then the save.
Bless you.
Thank you.
You guys aren't talking anymore? Means you guys are done? Right? You're good? Okay, points that we use. Can you please? Ryan, oh, where are you? Okay, can you tell me what point you use and how did you find it?
0, wait for 4.
For 4, yes. Sorry.
0, 4.
0, 4. And what did you do to get that point?
I moved the 5x to the other side.
Okay, so negative 2y equals negative 5x plus 8. And then?
And then I divided by negative 2.
Okay, so divided by negative 2. And then Ryan has positive 5 over 2, Ryan?
Yeah.
And then plus 4. And so what you're saying, this is the y-intercept right there? Oh, sorry. Good eye. Thank you. So Ryan, that's negative 4. So this is a negative 4, right? Like that? Okay. Good eye. Thank you. Okay, so that's your negative. Anyone else? Raise your hand if that's the method you did. That's okay. By now, if you have a system that you want, go for it. Okay? All right, the rate of change. So from this right here, you can find the rate of change right away. Paige, where are you, dear? Okay, Paige, can you tell me the rate of change, please?
5 over 2.
5 over 2. Thank you. Okay. Then we're going to say the domain. Okay. Shaughnessy, where are you? Okay, Shaughnessy, what's the domain? You're right, it is all real numbers. Okay. Can you please, Joseph, can you tell me the range?
The range?
Mm-hmm.
I'm not sure how to do the range.
So Joseph, the range means what? What are we trying to describe if I'm asking for the range? Look back at the definition. The range is, or consult your team. You have multiple choices.
Oh, it's all real numbers.
But why?
I don't know why.
What are we trying to describe? Ask your team. The range is describing what?
Oh, is it? It's like the range of the end of the graph to the arrow on the graph to the beginning.
Well, that can be the domain as well. But the range and domain are two different things, right? So the range is describing all values of what? Team? Talk to us about. Right. So Joseph, yesterday we graphed these already in this check for you up here. Okay. So, and this is really important. So I want to take my time to kind of explain this to you. So as you can see, the range is describing all values of what? So if you look at this, would this line eventually go lower and lower and lower and lower? Right? To what? To what number we call it? Negative infinity, because it doesn't stop. And then this arrow is going to go what? Higher and higher and higher to what? Positive infinity, because it doesn't stop. What makes it not stopping ever? The arrows. That's why the arrows are important, okay? Because of the arrows, they're going to go up and down forever, and therefore the range is also what? All reals, okay? From here, we can calculate the x-intercept, okay? So if you need to, you can totally consult with your team. Haley C., where are you? Can you tell me how to find the x-intercept? Okay, can you consult with your team and then come back to me? Yes, plug in 0 for y. Or yesterday I said you can take your finger and cover what if I'm looking for the x-intercept? X-intercept, I can take my finger and cover which? Y, cover the y, right? True or false? So it's left. 5x equals 8. Okay, so you can cover up the y, all the y term. So this means y is 0. That's why you're allowed to do that. So you are left with 5x equals 8. And then Haley, what do you want to do next to solve for x, dear? Very good. So x equal to 5, 8. I'm sorry, 8, 5. A little bit dyslexic there. Okay, or I can write it as an order pair. How would you write this as an order pair? Okay, an order pair, I need an X, yeah, that's okay. Perfect, or you can say 1 3/5, comma 0. Either one's fine. So 8/5, comma 0. Y-intercept, we found that already, right, class? Okay, so Joey S., where are you? Oh, good. Can you tell me the y-intercept? 0, comma 0, comma -4, right? Because it's the point we use on the top.
Oh, yeah.
Yeah, okay. Increasing or decreasing based on the graph. And by the way, what else can I base on besides the graph? The slope. Is my slope positive or negative? Positive. So is it ever going to be decreasing? No. So right away, I can write NA on my decreasing. It's not applicable. It's never going to decrease. So increase, how would you write this? Shelby L., where are you? Okay. Shelby, how would you write the increasing interval?
In parentheses, negative infinity, comma, positive infinity.
Perfect. Okay. And whenever I'm asking for interval notation, the smaller numbers must go first. Okay, here we go. Last part of today. Point use. I don't really have to do a lot for here, okay? Isabella A., where are you? Okay, can you tell me the point use?
4, comma, -2.
Great job, Isabella. Can you see that Isabella took its opposite? There's a -4 in there, but when you put it as a point, it has to be its opposite. Okay, so be very mindful. And then you see a positive y, but then we have to do its opposite, so it's now a negative. The rate of change. Griffin, dear, can you tell me the rate of change? Very good. The domain. Megan B., can you tell me the domain? Beautiful. Our range. Nick A., can you tell me the range? Beautiful. X-intercept, we need to kind of do a little bit of work, okay? So let's do it over here. X-intercept, Gabriella R., where are you? Can you tell me X-intercept, I have to do what with Y value? You're right, okay? Y equals 0, so this is 0 plus 2 equals -1/3 times x minus 4. And a lot of you are quicker with this, so you can do multiple steps at once. So from here, I'm going to distribute. So 2 equals -1/3 x. Tell me, -1/3 times -4 is what, class? 4/3. So a distribution just like that. Okay, so positive 4/3. Then I need to solve for x. By the way, raise your hand if you got rid of fractions before you solve for x. Okay, that's okay too. There are multiple ways. If you think, you know what, fractions usually give you more mistakes, then get rid of it. So I'm going to multiply each and everything by 3. That will allow me to write 6 here equals, bless you, -x plus 4. Then from here, I'm going to solve for x by subtracting 4 to both sides. Either way, you're going to come up with the same answer. So now I have positive 2 equals -x. That will give me an x-intercept at -2. Is that correct? Someone confirm that with me? Did we get a positive 2 or -2? Okay, so let's check this really quickly. We have a -1/3 times x, so that's a -1/3 x. Is that okay still? A -1/3 times a -4, that's a positive 4/3. Is that still okay? Verify that with me. Right, so that's a positive here. So can you see that this is, if I multiply that, so that's going to be 6. So check this right here. Is that correct still? The signs. -1/3 slope, right? So that's going to be -1/3 x. Someone verify that with me. A negative times a negative is now a positive. Is that still okay? I want to make sure the signs are right. I do make mistakes often, so I want to make sure we are all together. So if I were to multiply everything by 3, let's see if my signs are. Okay, so if I multiply everything by 3, raise your hand if you had a -2. I want to make sure who has what. And raise your hand if you have positive. Okay, so if I multiply everything by 3, this is 6 equals. Is that still a -1x? I just want to make sure that's okay. Is that still a -1x? Yeah. So it's a negative 1x, and that's still a positive 4, right, class? Okay, then I'm going to subtract 4 from both sides. So 6 minus 4, that's a positive 2, equals a negative 1x. Is that okay? Then now I'm going to get rid of the negative sign in front of x by dividing or multiplying. So x is just what? Negative 2? Okay, I'm going to go back to my graph to see if my value kind of correlate with the graph, because some of us are not very sure. And if my graph is wrong, then I should have, okay, so here's number 5. Can you see that x-intercept is at negative 2? Yes or no? Yeah, so your algebraic and your graphing should be exactly the same, okay? So that confirms that it's going to be at negative 2. I'm going to write negative 2 comma 0. Y-intercept, I'm going to set x equals to 0. So that means y plus 2 equals negative 1/3, 0 minus 4. By the way, 0 minus 4 is just what? Negative 4. So negative 1/3 times negative 4. I'm pause right there. Someone check my math. Is that okay still? A negative 1/3 times a negative 4 is what? Positive 4 over 3. Now, you can again get rid of fractions, or because it's just easier to subtract 2 to both sides, I would do that. So y equals 4/3 minus, do I have to find common denominator here? What's my common denominator? 3. So I'm going to make this into a 3. What that means is, what's the top number now? 6. Okay. So 4/3 take away 6/3 is positive and negative? Negative 2/3. Okay, so that's my y-intercept. I'm going to put it in as an ordered pair. So 0 comma negative 2/3. And if you doubt where that is, we can go back to the graph and look. Is it below the origin? Now, because the slope is negative, will you ever have increasing intervals? No. So right away, I'm going to go and write NA on my increasing interval. Okay. So Megan C, where are you? Megan C? Megan C? I don't have a Megan C. I have to check that card. Hannah A, where are you? Okay, can you tell me how would we write the decreasing interval? And then parentheses. Very good. Okay. And that's the end of our notes on graphing linear equations. Okay. Go ahead and take out your homework. Let me verify your answers. Okay. If you want to take out a different color marker or pen so you can grade your homework. Okay. So when you're studying, you want to focus on all the things that you're marking.